Alright, so in Chapter 10, we're going to be introducing this idea of organic chemistry. Um, Organic chemistry is the chemistry of what we designate as organic compounds, which can be tricky in terms of its definition. Okay, so you can pretty much try to divide all the compounds in the world up into two different categories, organic or inorganic. And I say try because it's not really possible. There are some things that make certain compounds organic. For example, organic compounds tend to contain carbon. So we'll say that they are carbon based. Okay, they tend to be found in living things. Okay. Inorganic things tend to be things that contain metals. Okay, and they tend to be found in non-living things. Okay, and I use these words tend very carefully because there is a ton of crossover between these two classes of compounds. For example, sure, inorganic compounds contain metals, but if you think about your blood, that has red blood cells, which contains hemoglobin, which contains iron, I think we would all agree that hemoglobin is organic, and it has a metal in there. Okay, so again, that gets to be a little bit complicated. There are compounds that are organic that are found in dirt. Okay, dirt is not living. These came from living things, but still. Okay, so the definition of organic versus inorganic is tenuous at best. One thing we can say for sure is that all organic compounds contain carbon. Okay, but an important distinction to make is that not all compounds that contain carbon are necessarily organic. For example, if you think about something like sodium bicarbonate. Okay, sodium bicarbonate is baking soda. Baking soda is not a living creature, but it has carbon in it. So technically, we kind of throw sodium bicarbonate into this inorganic end of things. Okay, but the take home here is that all organic compounds have at least carbon in them, but not all carbon containing compounds are not all carbon containing compounds are necessarily organic. So generally what we say is that if we see a molecule that contains elements like carbon, hydrogen, nitrogen, oxygen, and sulfur, then for the most part we'll put that into the organic category. Okay, and that's about as best as we can do in terms of categorizing between organic versus inorganic. Don't get too caught up in that. Now, the big question that comes out of this discussion is why carbon? Okay, what is it about carbon? Okay, so what makes carbon so special? Carbon is able to do some things that many other elements on the periodic table are not capable of doing. First of all, it forms bonds with virtually every other element on the periodic table. I'm just going to say it forms many different types of bonds. Okay, so it forms bonds to oxygen, nitrogen, other carbon atoms, sulfur, phosphorus, etc. Not only that, carbon can form different geometries. When I say geometries, you need to think about molecular geometry. Okay, when we talked about all the different shapes that molecules can have. So if you think about carbon that's bound to four things, okay, then you would have tetrahedral carbon. Okay, so in that case we had four different groups, okay, coming off that carbon in that tetrahedral arrangement with the bond angles of 109.5. Okay, but we can also have carbon that's bound to just three things. We call that trigonal planar. Okay, and that happens usually when we have a carbon that's involved in a double bond. Okay, in that case, those bonds are about at a 120-degree angle. Or we could have carbon that's linear. Okay, carbon that is bound to two things. And this typically happens when we have carbon involved in a triple bond. And here the bond angle is 180 degrees. Okay, and finally, probably more important than many of the other factors here, carbon is able to form bonds to itself. So we can make long chains of carbon atoms. This is called concatenation. Okay, so I can have a carbon compound that has two carbon atoms, or I can have one that has four carbon atoms stuck together. And there's even compounds that go up to literally tens of thousands of carbon atoms stuck together. Okay, now when you start putting all these three factors together, what you start to realize is that carbon is very diverse. It can make a lot of different molecules, a lot of different shaped molecules, molecules with different reactivities because of the different bonds that it's forming. Okay, and it's this diversity that is necessary for life as we know it, to have all the different types of proteins and enzymes and fat molecules and sugars. Carbon is set up perfectly to create that diverse number of molecules. And when we come back in the next video, we'll talk about different types of organic compounds.